The next thing we're going to talk about is the degree of unsaturation in a molecule. And we spent a little bit of time on this already, but basically we know that every loss of 2 hydrogen from a saturated formula is 1 unsaturation. So what we're going to do is look at some different C5 molecules. So we're going to start with just an alkane, then we'll look at carbon 5 alkene. Let's look at a 5-membered ring. Then maybe we'll also look at 5 carbon with 2 double bonds and 5 carbons with a triple bond. And remember how we draw this triple bond, we keep this linear here instead of coming down in kind of the zigzag structure, because this is an sp hybridized carbon with a 180-degree bond angle. So the saturated alkane has a formula C5H12. Okay, now when we incorporate a double bond into the structure, the formula becomes C5H10. We lost 2 hydrogen, and therefore this double bond is equivalent to 1 unsaturation. Likewise, if we move to the ring structure, we have our 5 carbons. Every carbon in the ring has 2 hydrogen. The formula is also C5H10. So this lost 2 hydrogen relative to the saturated formula. So this has 1 unsaturation. So now let's come down here to this structure where we have 2 double bonds. We still have 5 carbons, but now each double bond resulted in a loss of 2 hydrogen from the formula. Now if you want, you can draw your hydrogens in. We have CH3 here, H, 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 and H. So now the formula is C5H8. So what does that tell us? Well, that tells us that we lost 4 hydrogen, and this is 2 unsaturations. There's 1 for this double bond, 1 for this double bond. When we have the triple bond here, the formula for this structure is C5H8. So again, in comparison to our saturated formula, C5H12, this molecule has lost 4 hydrogen, which means it has 2 unsaturations. Why? Well, the triple bond is 2 pi bonds. So 2 unsaturations from one of the pi bonds, 2 unsaturations from the other pi bond. So to summarize, we can make a couple of generalizations here. We can say that for every double bond in a molecule, you're going to have 1 unsaturation. For every ring in your molecule, you'll have 1 unsaturation. And from every triple bond in your molecule, you'll have 2 unsaturations. In addition to figuring out how many unsaturations a molecule has, we can actually do this from a molecular formula as well. And this is something that's going to be a little more useful to us later on when we start to do NMR, where we're given a molecular formula and we have to figure out the structure from that formula. We're going to learn how to do this calculation. Basically, you can get the number of unsaturations by taking 2 times the number of carbon in your formula plus 2, subtract the number of hydrogen, subtract the number of halogens, add the number of nitrogens, and divide all of that by 2. One notably absent atom is the oxygen. If you have an oxygen in your formula, just ignore it. So let's do a couple of examples. We'll just start with the hydrocarbon, C13H14. So now, using our calculation, the number of unsaturations is 2 times the number of carbon, which we know is 13, plus 2, minus the number of hydrogen, which we know from our formula, the number of hydrogen is 14. And we don't have any halogens or nitrogens to worry about here. So all of that divided by 2. So that ends up being 28 minus 14 divided by 2, which is 14 divided by 2, which is 7. So whatever structure this is, it has some combination of rings and pi bonds that total up to 7 unsaturations. All right, so now let's look at one that's a little more complicated, a larger formula, some other atoms in it. Let's do C5H10 N2O BrCl. So kind of a long, complicated formula there. But from our calculation, we do 2 times the number of carbon, which is 5, plus 2, minus the number of hydrogen, which is 10, minus the number of halogens. Well, we have a bromine and a chlorine. So we subtract 2 halogens, and then we add the number of nitrogen. There's 2 nitrogen. And then the oxygen, as we talked about before, just ignore that. So then all of this divided by 2. So if you do the math, you should get 12 minus 10 divided by 2, just 2 over 2, which is 1. So this compound, despite this long complex formula, it either has a double bond in it or a ring, no other unsaturations.